Okay. So today, we're going to, well, if we have time, we'll come back to homework answers, but I'll make sure that I post this up on School Loop so that you have it and so you can go back and look at it. I don't think we have enough time for heads up, although I think it would be fun. How do you guys like heads up? Okay, maybe if we go to the end and we have time, we'll come back to it. Sound good? Okay, students will be able to solve quadratic equations using multiple methods. Today, we are putting it all together, okay? I know very, very little different things you'll see between me and the way Ms. Liz and I will present things. If it confuses I'm showing you, don't worry, just do it the way you know how to do it, the way you were taught, the way she does it. But some of these little things that I do there differently that you may see help you out a little bit. Okay? All right, so let's start here. I'm trying to make a perfect square trinomial. Okay, so I'm trying to make a perfect square on this side here and a perfect square on this side here. I have 4 x's to work with. So if I'm looking at this pictorially, I would take those 4 x's and I would cut them in half. 2 x's over here, 2 x's over here. If I have 2 x's here and 2 x's here to make a square, I would have 2 squares, or 4. Right? If we were up, it would be broken up into 4 pieces. Now the way I choose to write it is 2 squared. You guys okay with that? I don't think Miss Liz says it that way. Miss Liz would write it like this, right? Which is perfectly fine. It's the way most teachers write it. The reason I write it like this is it reminds me that I have to have a perfect square on this side, and I have to have a perfect square on this side, because when I combine them, I'm going to have, let's do this. See how they're both going to be squared? I'm going to have x and a positive 2. Right? So it's almost like if you keep it there, you know you have an x and a 2, and that's what goes inside the parentheses. Okay, so just a little different how I do it. If that confuses you, just stick right with this. It's right here. Just like she showed you. Okay? Just a little difference. That's the way we do things. All right. This screen. Now, I don't like it anymore. Ms. Liz is using what I used last year, but I think there's one little piece of it that needs to be fixed a little bit. And I'll tell you why. Let's do this. Before I did it on the board, because I can see what she has over there, but right now I want to do it for the purposes of the video. Let's do this. Let me take a picture of this. Take a picture of that. And normally, we would split this x equals negative b over 2a. Ms. Wiz explained to you that this is your what? Good. That's your axis of symmetry. And this over here, we're going to have plus or minus the square root of b squared minus 4ac all over 2a. What is this? This part right here is not the discriminant. This whole thing is not the discriminant. The discriminant is right here, which I should have made that orange because it's orange up there. This part is the discriminant, right? This part, the whole thing, is where we move. For instance, let me give you, oh, look at, it's a cute little apple I was demonstrating for another teacher. Get rid of the apple. Okay. All right. So, for instance, if I have my axis of symmetry, we'll say it's at see, what color we want to make it? Blue. I heard blue first. So here's my axis of symmetry. That's this part, my axis of symmetry. This part is where I move in the positive direction and in the negative direction off of the axis of symmetry. That's why you see this. Okay? It's the movement that we're making. This part tells me how many roots I'm going to have, whether I'm going to cross the x-axis twice, once, or not at all. But the whole thing tells me how far away I'm going to be from my axis of symmetry. If it's no roots, it would be like this, right? If it's one root, it would be like this. If it's two roots, it would be this far away here, something like this. This is why I'm writing this. I'm taking the time to write this. This is why. This is the biggest mistake students make. They forget the 2a on this side. And I'm going to give you something concrete to explain it. Check this out. Let's say I were to say to you, 8 plus 4, and you're going to think that this is so silly. What if I told you that I want to know what 8 plus 4 over 2 is? Can you tell me? How do you know? Seems simple, right? Because it's 12, and you divide it by 2, and you get 6. So technically, isn't 8 being divided by 2 and 4 is being divided by 2? Now, if you compare that to this, which it is exactly, this is just a bunch of letters, and it looks a lot more complicated. This is something you learned probably back in 4th grade, right? Couldn't we break this up and say 8 is being divided by 2 and 4 is being divided by 2? So 8 divided by 2 is 4, and 4 divided by 2 is 2, still makes 6. But here's the biggest mistake Algebra 2 kids make. When they split this up, when they split this one and this one, see, I'm trying to use my pointer so people can see if they're watching the video. When they do that, and put it in red because it's a mistake, they do this, which is the wrong way to do it. I'm going to write wrong for using X's. Wrong. Wrong way to do it. They would split up the 2 and then add the 4. Is that going to give me the right answer? Do you see what I'm saying? When they split it up, that's why I don't like this screen that I made last year. Because it says, oh, we're going to split it up and you're going to leave over 2a, and then we just have b squared minus 4ac. So what did I forget? It's going to be divided by 2a. Which, if you know your stuff, you're like, Mrs. Muller, that's obvious. But I'm telling you, it's the biggest mistake. So this is the discriminant right here. This is the discriminant, but this whole thing is what? How far we move left to right. Okay? All right. I know this is all review. I just want to put it in a different context for you. Okay? Because you got a test coming up. All righty. Do you guys understand how I compared this to this? Okay. Okay. So again, discriminant. If there's a negative underneath the square root, we're going to say plus an imaginary number and minus an imaginary number. So we're not going to have any roots. This one, we're going to say plus 0 and minus 0. We're not going to go anywhere. There's only one root. I don't have 2. This one, I'm going to get x, and I'm going to get minus 6. Am I going to move 6 spaces to the left and 6 spaces to the right? Yeah. No. What am I forgetting? You have to divide by 2. You see what I mean? How you could forget that piece of it? So I want you guys to be really careful. The front piece of that would have been the negative 2 divided by 2. I should move this. No. How come I'm touching here and it's coming up here? There we go. Move that over. So these are my 2 roots. X equals, X equals. Gives me 2 roots. Come down. How are you guys doing? Because I shouldn't be talking this much. I shouldn't talk more than 10 minutes. But I'm trying to review really quick, and then we'll get going. I don't know unless you show me. Thumbs up, thumbs down. Thumbs up, thumbs down. How are we doing? Awesome. Okay. So I want you guys to just look at the board. I didn't say this very well in the last class. I've been holding my phone down. I hope it's still picking it up. We'll see. So in the last class, I explained this wrong. I want you to figure out which one you would use. Not for all 3 of them, because you never want to consider one way to do all 3. It's just like I talked about my kids. I wouldn't discipline all my kids the same. I discipline them in different ways because different things work for different kids. So different methods are going to work for different problems that you come up with. So think about it real quick for about 1.5 minutes. Look at each one of them and try and decide whether you would factor, you would complete the square, or you would use the quadratic formula, and be ready to defend your thinking. Nobody's wrong with anything that they do, okay? You just have to be able to defend yourself. I'm going to go ahead. 5, 4, 3, 2, 1, recording. Okay, who's ready to tell me what they would do? Amadeus? Okay, let's be respectful to Amadeus while we listen to what he said. So I think I heard you say you would factor, and why would you factor? So if you subtract 2 from both sides, you would get? Good. We'll say, I don't want to squish it in there. I would factor, it has an equal sign, so technically I should keep the equal sign with it. So p squared minus 7p plus 10 equals 0, and then we would factor it from there. So that makes it look prettier. Correct? And you said 5 and 2? Yeah. And 5 and 2 must be? Because? Because of the negative 7. Thank you. Because negative 5 times negative 2 is positive 10. Perfect. Anybody who would a different way? No? What if I said I wanted to complete the square? What would you say?
You have to subtract 12.
I'd have to subtract 12. What else? Why else would it not be appealing to complete the square?
You have to divide it, becomes 3.5.
Yeah, if I divide that 7, it's 3.5, or 7 halves squared. That's not fun, right? Is it doable?
Yeah.
It's doable. Do I want to work with that? Nope. Okay. What about this one? Do we want to something different? Nobody? You're Matthew. Matthew wants to complete the square. You guys agree? What's the most appealing reason why you would pick you would complete the square, Matthew?
Because the perfect square and 8 gives you 60.
True. It's an even number. That's what makes it appealing. What's another really appealing piece to it? There's nothing over here. We don't have to move anything, right? It's all ready to complete the square. So I'm going to complete the square on this one for you guys. So I have x squared plus 8x. Again, I do it a little different, right? Plus something equals negative 18 plus, what else do I need on this side? Another something, right? Because I have to, in order to keep it equal, I've got to add the same thing to both sides. Half of 8 is 4. So I know my perfect square is 16, or 4 squared, which leaves me with plus 4 squared equals negative 4, negative 2. Can't count. Are we good? Immediately something's red flag.
The negative.
The negative. Why?
It's square root.
You have to square root it, so what's that going to mean about this? I'm going to have imaginary roots, right? Awesome. What's this one? I'm hearing quadratic from quite a few. Does anybody want to raise their hand and defend? Say it again. Is that you, Princess What? You could just plug it in. What do I have to move first before I plug it in? The 7. Why? It has to equal to 0. So 4n squared minus 4n. Now it's going to be a negative 7. So now I have my a equals 4, my b equals negative 4, and my c equals negative 7. Why wouldn't I factor this? You can't divide 7 by 4. That's not why you can't factor it. I don't know. Let's use, what color? Let's use blue. Magenta. I don't have magenta up there. Okay, in order to factor, what does it have to be equal to? Still need it in this form, right? Let's try it. Somebody said in last period that the reason I want to factor it like this is because the 7. And I argued, I said, no, I think the 7 works well because 7 only factors into one thing. 7 and 1. That part's easy. The part that makes it hard is the guessing on the other side. Because 4 can be 4 and 1, it can be 1 and 4, and it can be 2 and 2. So we kind of have to try everything out, right? So let's try what you guys want to try. 2 and 2, so 2n and 2n. Okay, this is something I think, I thought Miss Ruth does it like this, but maybe she does it later on in the year. The way I check these is I call them rainbows and checks. So it's like a foil, but I do it right within the problem. I actually do it in my head, but I'll tell you what I'm doing in my head by writing. Make sense? So I have 7 times 2 is 14n, right? That's my inner. My outer is 2 times 1. Together they make 16n. Is that going to get me negative 4? Nope, so that doesn't work. So by factoring, if you have that coefficient is bigger, coefficient's bigger than 1, it's a bunch of guessing. What do you want to try now? 4 and 1? Let's see. 4n and 1n. 7n and 4n. 7n and 4 make 11n. Does that work? Nope. Now we're going to try last time. 1 and 4. n and 4n. 7 times 4 is 28. I immediately say to myself, there is no way that that's going to make 4n. Okay? So is this factorable? Nope, it's not. Well, so then we would go to quadratic formula, which a equals our beta. Okay, I think I'm done talking. I think that's enough of me talking. It's already 18 minutes. I don't think we need to do this exercise again. I think we're pretty good. I got thumbs up before I even started it. Let's play this. This is fun. Which one doesn't belong? So take a look at it. Like 30 seconds. I'm going to pause it. What do you guys? 4, 3, 2, 1. Recording. Okay. What do you guys think? Hands. Let's hear it.
The green one because it is the only one that has multiple factors.
Only one that has multiple x squared. I like how you said that. Yeah, it does have multiple x squared. Because you know what? I would draw that, because I'm silly like that, multiple x squared. There's 6 of them, right? Dot, dot, dot. They could be said a different way. How else could you say that? Coefficient is greater than 1. There's another way to say it. I can pull out a greatest common factor. Who said it first? Yeah? Okay. If I had candy, I would be handing it out because that's great vocabulary. Give it to you? Give it to you? I don't. It's gone. I don't know what happened to it. You leave for a couple weeks and there's no more candy. Okay. 5, 4, 3, 2, 1. Does somebody have another way or another reason why something doesn't belong? The blue one because it equals 5 and none of them equal 0. Nobody got that one last period. And it's not plus or minus anything. What else? It's not true. Ooh, I love that you brought that up, because check this out. If I were to pull GCF, look at this. That one actually has perfect square roots right there too. But I like what you're thinking about. Let's bring this back down. So actually, if we were to argue that one, you could argue that this one doesn't belong because that's a perfect square, that's a perfect square, and that's a perfect square. Right? That's what they got in last grade. What else? There's more.
This one doesn't have to do with the numbers, but the blue one's the only primary color.
Isn't green a primary color?
No, blue and yellow.
It's blue, yellow, red.
Okay.
But it's in the rainbow.
There we go.
The orange
Wait, tell me your name.
green.
Grant.
The orange one doesn't belong because for the blue one, if you move the 5 over, then for all of it, it would be the variable minus something around.
Did you hear what he said? He said that if I were to move it over, because they're all not equal to 0, if I were to make this equal to 0, it's the only one, the orange one's the only one that's adding something, which ties into one more thing, and it's the only one that I really, really, really want you guys to know. You like that? Anybody have it? I wish I had candy. Such an incentive.
I like taking hints.
A hint. Okay. You guys talked about positives and negatives, and the reason that this one doesn't belong is because these are all minus 5, minus 49, minus 24. This one's plus. There's a hint. Minuses and positives.
Is it, say this question like how 5 is plus or minus? 5 is multiple.
You're thinking, you're on the right track. You think you have it? It does have something to do with imaginary numbers.
Oh,
Why?
N squared.
Okay, let's hear it.
The orange one would be the only one with the imaginary number.
The orange one's the only one with imaginary numbers. Why? Take it one more. How do you know?
Subtract 1, and then negative 1 on that side.
And then you have to take the square root of both sides, hence imaginary numbers. You guys are so ready. Okay. All right. GCF, obviously, I've been talking a lot with junior high teachers, so pardon me, I'm going to bring it back to simplistic. That's the difference between, I think one of the only differences between myself and Ms. Wiz is I always want to bring it down to the simplest thing. I don't know. Does that make me more simple than her? She's more complex? Okay. So, if I think about this with elementary school kids, right, they talk about scale up and scale down. You guys remember that?
Yeah.
So this is an example of scaling up. If I half and I multiply by 3 over 3, I just scaled up, right? But I can also scale down. If I have 4/8, I could scale it down to 2/4. I could further scale it down to 1/2. Well, these are scaled up, but just algebra. This one scaled up by how much? 2. Each one of these could be, I could 2 out of each one of these. This one scaled up by 3. Those are good. See how it's much easier if you think about it in a simpler aspect, right? I swear I'll try the whole year for you guys. Every time I see something that's algebra, I'll try and tie it to something that you learned in elementary. It really is just glorified elementary school. Can I argue that one? Is that too silly, Mr. Easton? You can almost tie everything back to something, some structure.
I have a question going back to scaling up and scaling
Is
down.
he, okay.
Because your examples, those are equivalent.
Yes.
But if you factor out a 2 or factor out a 3, those really aren't equivalent. multiplying by 2, we're multiplying by 2.
Well, I guess what I'm saying is that this will be equivalent to this. But yes, I knew I was going to get in trouble with that one. You guys understand what he's saying? These, we don't know if these are equal right now, right? But I can say that this is equivalent to this. Yes? No? I still can't? I still can. Are you going to make it further complicated on me and tell me that if I were to... Yeah. Okay. Are we good? Okay. All right. So the last thing we need to do is we need to come up with our cubes. 25 minutes. All right. So you guys have been talking for a little bit, right? Okay. All right. Let's go through this really super quick. I think we've already covered all of them, but I don't want to tell you. I want you guys to think about it. Let's go. What do you need to factor?
Negative balance.
Okay, so people get really mad at me. Students get mad at me when they're like, but I said that. Well, I didn't hear you because like 10 people said it or said different things and I couldn't hear it. So somebody raised their hand. Okay, we need something. Technically, no. If I had, yeah, you do. You need x squared. You do need an x squared. True. What else?
Greatest common factor.
We need to get rid of a greatest common factor. Has to be equal to 0. Those are our main ones. Okay? Thank you. Perfect. I do want this one recorded. So thank you for keeping an eye on that for me. What about quadratic formula? Tell me what I need to do right now. Look at my calendar. Okay. Quadratic formula. What do I need? We need A, B, and C. In order to get A, B, and C, it has to be equal to 0. Isn't that about all I need? Technically, for quadratic formula? Completing the square. What's ideal? Okay, again, everybody's yelling at me. Raise your hand. Okay, over here. You have to make perfect squares, like this. You have to make a perfect square. Right? What else? We need to know what we need a perfect square, what we need to add to both sides. Gotcha. There's one more thing that's ideal. Not necessary, but ideal. Okay.
It should be.
It would be easier. It would be. I don't know it up there, but you're right. Absolutely. Okay, I'm going over here. Giggling, you must be bored, so help me out. Why didn't you tell me? How long have I not had it in my hand? I'm really, really sorry. Okay. I'm talking to my phone right now, telling you, whoever is listening, that I'm really, really sorry. And that's why you said it, Grant. Right? Okay. Did I set it down and then you raised your hand and said you're recording? Okay. All right. So we can work on that, right? Okay, let's go back. Complete a square.
Like that square was like that.
It has to do with when we split and square. It's going to end up being a square root. You guys need a visual. Would you use completing the square? I heard it, but nobody raised their hand. Which one is more ideal for completing the square? It has to be, you want B to be even. You want it to be an even number. It can be odd. I put that in the wrong place. Okay. Finally, ideally, and I could show you guys how to do it if you have a coefficient, but I'm going to, because we don't need to get that in depth right now. But technically, if I were to show you how to do this with pictures, don't I do this one with pictures like this? X squared, and then 3 x's, and 3 x's. Well, this one I would have to show you as you've got 4 of them. You know what I mean? It's kind of crazy when you do it with pictures, but when you do it with algebra, you just put a 4 on the outside. But you always, you have 4 of them. So technically you can do it. It's not that hard. It takes a little bit more practice. But this one you could use quadratic formula a lot easier. Why would quadratic formula be personally Mrs. Muller's last go-to? Can anybody guess? Think about it. Okay, that's not why it's longer. It's really, you got to keep track of all the negatives and the positives and make sure you distribute that division to both sets, the axis of symmetry, and how far you have to move. There's a lot of places to make errors, right? Doesn't mean you can't use it. How many of you is quadratic formula your favorite option? You guys don't have to not like it just because of me. It's simplistic, right? You said go-to. You could forget one of the steps. Okay, so with quadratic formula, this is why it's my least favorite. You can make your most errors, and way to check to see if you're right is to do what? Substitute it back in. If I use factoring, I could FOIL and I could see if I'm right. If I completed the square, right, you can see it. You've got pictures. So I'm glad none of you said that quadratic formula was your favorite, because today's exercise is to use all 4. So what I'm going to do, so we're going to put all this together. So you're going to use all 4. The beauty of that is it's like having 4 checks, or I guess technically 3 checks. All right. So I'm going to give you your worksheet. I'm going to go ahead and pause this. You guys are going to work on some for about, how about work on this one for about 3 minutes, and then I'll do all 4 squares for you. Okay? Sound good? 5, 4, 3, 2, 1, recording. We forgot our graph. Okay, not necessarily what do we need to know, but what do we get from the graph? Yes?
If it's a positive, you got 2. If it's a negative, you got 1.
Oh, you're talking per minute. Good job. We're just talking about just a basic graph. Here, I'll give you a, not x, well, if I have something like, let's go to this one. If I have x squared minus 6x plus 5, minus 6x plus 5, what do I know right off the bat? I know the y-intercept. After I can figure out the y-intercept, what should I do next? It's almost like a puzzle that winds itself, right? Like one piece of the puzzle gives you 2 more pieces of the puzzle, gives you 3 more pieces of the puzzle. After your y-intercept, you got that right here, it's 5. What could you do now? Factor. Once you factor, now what are you going to have? You're going to have your, can we say x-intercept, can I write roots instead, just because it's shorter? Same thing, roots, x-intercept. Once you have your, now I've got a graph that's got roots. What piece of the puzzle can I get from having roots? Exactly. This is my y-intercept. That's right here. Now I could get my axis of symmetry, because I can go between, right? Gives me my axis of symmetry. Is it going to let me write underneath that? Axis of symmetry. Finally, my axis of symmetry tells me what x equals, right? And so if I know what x equals, I can now figure out what y equals. So now I just substitute it back in. Okay, I lied and said I was going to give you 3 minutes, but I want to get that last part in so we can get our vertex. It gives us our y. So I want to honor the fact that I said I was going to give you some time. So another minute or so. And recording. Okay, so I'll do number 1 with you guys. All right, first thing I'm going to do is factor, which we already did on the previous example. So this factors out to x and 5 and 1, and they both have to be negative because the 6 is negative. Check it with my rainbows and checks. Negative 5x, negative 1x makes a total of negative 6x, so we're correct. So my solutions are x equals 5, x equals 1. Let's complete the square. What do I need to do to complete the square? What do I have to do to this 5? It's not a perfect square. I need to make this a perfect square. Sorry, I need to make this a perfect square. So I need to put it on the other side. So I need to add something to make it a perfect square, put my negative 5 on the other side, and then I need to make sure I still add it to the other side so we're equivalent. Equivalency is the key. Okay, what am I going to put in there to make it a perfect square? 9? 6 cut in half is 3. 3 squared is 9. So now it becomes x3 squared equals 4. And you guys should be, Mrs. Smaller, I see so many things right there. You should be able to see that your axis of symmetry is going to be 3. Right? Because when you square root both sides, you're going to have a 3. That's what I'm going to do next. Square root both sides. Got squared. That's why we complete the square, so we have perfect squares. So now this becomes x minus 3. And this becomes plus or minus 2, right? Because it's going in both directions. Then when I bring the 3 over, it's going to be x equals 3 plus or minus 2. What am I seeing right now? What's the 3 stand for? Axis of symmetry. What is the 2? The distance you're moving from your axis of symmetry. So I'm going to move in the positive direction 2 spaces, which gives me 5. And I'm going to move in the, x equals, I'm going to move in the negative direction, which was going to give me 1. Do I have the same thing as I had from factoring? 5 and 1? C. Quadratic formula. Do we have time? We have 3 minutes. Let's graph first and do the quadratic formula last. You have to, I'll show you what you have to show right now. I'm not going to do formula first because quadratic formula is just computation. Graphing takes more. That's my only reasoning. Okay, so I already know that x is 5 and x is 1 are my roots, right? So that part I already know, right, Amadeus? 1, 2, 3, 4, 5. What else do I already know? Well, no, before that. Y-intercept, it's right here. 1, 2, 3, 4, 5. Now what else do I know? You know it's going up because of this. Exactly. But I know my axis of symmetry is in between. So my axis of symmetry is here. X equals 3 is my axis of symmetry. I also know another piece of information because I just found that axis of symmetry. We're doing before the vertex. There's already another point I can put up there. So since this is axis of symmetry, it means it's symmetrical on both sides. So since there's a point 1, 2, 3 away, I know there's another point 1, 2, 3 away. Now all I need is my vertex, and I have half of it already. We'll just leave it here. I have half of it already because I already know that x is 3. I like to use the factored form. This right here, my factored form, I'm going to use it over here. X minus 5 times x minus 1. I know that x is 3, so 3 minus 5, 3 minus 1. 3 minus 5 is 2, 3 minus 1 is 2. So y must be negative 4. Does that make sense?
Yeah.
Let's see. 1, 2, 1, 2, 1, 2, 3, 4. Does, let me put in a different color. Look at we were having, didn't even know it was time to leave. You guys, I'm going to check. You guys keep quiet because I'm still recording. Check this out. Square, if I go over 1, square 1, what do you get? 1. Square 2, what do you get? No. 2 squared is what? 4. 1, 2, 3, 4. Bingo. Square 3, what do you get? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Square 4, what are you going to get? 16. Square 5, 25. We'll talk about that later. It's a pattern. Good job, guys. Bye. Have a good